Hello, everyone. So now we'll be having an online session for discussing problems on limits. We have already done the theory of it in the classes, but there's quite a fair bit of problem solving that is still left on this particular chapter because, well, as I said earlier in the classes as well, that limits is basically the basis of whatever we do in continuity and differentiability. So we'll go through a set of problem solving for limits so that when we do the same for continuity and differentiability, we can deal with it in a shorter time. Yeah. So we'll start with some very basic, simple questions on limits, just to understand the concept and just to revise the concepts rather, the things that we have done in the class. For example, let's say question, find limit extending to 1, x by box x.
Does not exist.
क्या नमन?
Does not exist.
नहीं, not exactly, does not exist. Well, we are asked to find the limit at 1. And we know that for box x, 1 would be a key point. So in order to solve this limit, what would be the necessary mechanism? We have to split this into LHL and RHL. Now, the LHL of this would be limit x tending to 1 minus x by box x. And the RHL would be limit x tending to 1 plus x by box x. But then when you look at the left-hand limit, what is the problem with it? That if x is slightly less than 1, then box of it will become 0. Okay. Which means if you look at the domain of the function, what would be the domain of this function? All real numbers minus
Minus integers.
0 to 1. So the left-hand neighborhood, this that we talk about, is outside the domain. Which means we will not consider this. Since it is outside the domain, we will not consider this. We'll solve the question with the domain that is within the region. Okay, one-sided limits. This would be an example of a one-sided limit. So we solve it with the part or the neighborhood which is within the limits, which is only the right-hand limit. So 1 plus p box x would be 1. So this will end up becoming limit x tending to 1 plus x, which is 1. So the limit value will exist and is 1. Clear, everyone? Okay, next question. If fx is equal to sine of box x by box x whenever box x is not equal to 0 and 0 when box x is equal to 0, then the question is find limit x tending to 0 fx. Anyone? Again, 0 would be a key point, so we'll have to split this question into LHL, RHL as well. So LHL would be limit x tending to 0 minus fx, and RHL would obviously be limit x tending to 0 plus fx. Can anyone tell me what should we write fx as for the left-hand limit? For the left-hand limit, 0 minus fx would be sine of box x by box x. And what would be fx for the right-hand limit?
Zero.
Correct. Limit x tending to 0 plus fx would be defined as 0. Why so? Because fx is 0 whenever box x is 0 and box x is 0 for all values of x lying between 0 to 1. So that means for all values of x lying between 0 to 1, fx is 0. So in the right neighborhood, the function is behaving as a 0. And in the left neighborhood, the function is behaving as sine of box x. Okay, so RHL to 0 ho jayega. What will be the value of LHL? Sine of box x by box x as x tends to 0.
1.
Wrong. This will end up becoming a case of exact values versus tending values. If x is slightly less than 0, तो box का value क्या होगा? -1 हो जाएगा ना? So this will end up becoming a sine of -1 divided by -1, which is sine 1. So the left hand limit is sine 1, right hand limit is 0. So the limit does not exist. DNE हो गया answer. अच्छा, next question. Limit x tending to 0, root over of 1 minus cos 2x by 2 whole divided by x.
One by root 2.
1 by root 2. Let's check. Limit x tending to 0, 1 minus cos 2x हो गया 2 sin square x. So 2 to cancel होके sin square x आ जाएगा. So we'll have a root over of sin square x by x. ठीक है. तो रूट 2 कहाँ से आ गया? रूट 2 तो 2 के साथ
अरे
कैंसिल.
नहीं, हाँ सॉरी सर, मैं वो रूट 2 बाहर रख लिया था.
ठीक है. अच्छा, अब इसके बाद if you do it like this, root over of sin square x is sin x by x and then the value is 1. तो ये wrong है.
सर एलडी होगा ना.
LDE होगा. Why so?
तो प्लस माइनस साइन एक्स लेंगे.
Mod x
Because
mod
I
sin
have
x.
already said this multiple time in the classes. Root over of x square for all functional purposes is mod x. So when we try to simplify root over of sine square x, this would come out to be limit x tending to 0 mod of sine x by x. And for mod of sin x equal to 0 is a key point. Sin 0 is 0. And whenever the entity inside becomes 0, mod ke liye key point hote hai. So we will have to split this into LHL, RHL. LHL of this would be limit x tending to 0 minus. If x is slightly less than 0, sign negative hoga. So this will become minus of sin x by x. And x positive के लिए, delta positive के लिए sin positive है. तो sin x by x. तो इसका left hand limit हो गया -1, right hand limit is 1. Therefore, the answer is DNE. Limit doesn't exist. Please do remember root over of x square is mod x. This is vitally important for limit cases. Is everyone clear till here? Okay, then we move on to the next sets. Next question. Find limit extending to 0, 1 minus cos of 1 minus cos x by sin power 4x. As x tends to 0, what is the form of the limit? 0 by 0 hai, but we'll not be solving it at Lapita because as you realize, cos of 1 minus cos x ka derivative will become very complicated. So the method that we use to solve this would be converting to standard limits. Okay, now let's look at how do we convert this to standard limits. Limit extending to 0, we start with the numerator. What is the standard limit for 1 minus cos x? So 1 minus cos of something needs the square of that thing. 1 minus cos x, cos x by x square is half. So we multiply and divide with that something का square. तो यहाँ पे आ जाएगा एक 1 minus cos x whole square. Okay. Now next, what would 1 minus cos x need to become a perfect square, to become a standard limit? तो इसको एक square चाहिए. And with a square, this will become x power 4. So then we multiply by x power 4 and then we have a sin power 4x. देखो, is everyone okay with this? ये समझ में आया? This is the general process of converting to standard limits. Is everyone okay with this?
Yes, sir.
Okay.
Yes.
So now 1 minus cos of something by that something square as that something tends to 0. As x tends to 0, cos x will tend to 1. 1 minus 1, 0 हो गया. इसका वैल्यू क्या आएगा? So this would be half. 1 minus cos x by x square whole square. So this would be half ka whole square. So this would be 1 by 4. And what about x power 4 by sin power 4? 1. So the final answer for the
1.
limit of this, 1 by 8. Is everyone able to understand this?
Yes, sir.
Okay, next question. Limit extending to 0, x square into cos of 1 by x by sin x. Okay, so for this, we just slightly rearrange the terms in this way. Limit x tending to 0, x into cos of 1 by x into x by sin x. And now if you try to solve for the limit, what would be x by sin x, x tending to 0?
1.
This is tending to 1. Achha, as x tends to 0, x will be tending to 0. Now the problem is, how do we deal with cos of 1 by x? As x tends to 0, 1 by x will tend to infinity. So this part will actually end up becoming something like cos of infinity. How do we deal with cos of infinity? So we apply range restriction in the sense that cos of anything, infinity be kyun nahi ho, where will it lie between? It will be a number lying between -1 to 1. It will be a finite number lying between -1 to 1. Cos of infinity be kyun na ho. So in that case, we will replace this as a number lying between -1 to 1. And now let's look at what happens. So a number lying between -1 to 1 into 1 remains the same. Into 0. क्या हो जाएगा?
0.
0.
So the answer of this would be 0. Although we have a cos infinity, but we use the fact that cos infinity is a bounded function. It is a range restricted. It has to lie between -1 to 1. Hence, the value would be 0. Clear? Okay. Next topic. We'll do this as a topic. Application of binomial. Application of binomial expansions. We'll do a couple of questions on the applications of this. Okay. Question. So suppose we have something like this. Limit x tending to infinity, cube root of x cube plus 3x square minus root over of x square minus 2x. Since it's a limit extending to infinity, can we just go ahead and do it by the coefficient of the highest power method? One minus 1, 0. Will that be correct?
सर रैशनल फंक्शन नहीं हुआ सर.
No.
Correct. It is not a rational function क्योंकि यहाँ पे सिर्फ न्यूमरेटर है, डिनोमिनेटर नहीं है. Can we convert it to a rational function? No, this cannot be converted into a rational function as well, because एक पे cube root है और एक पे square root है. Had both of them been square roots, then we could have rationalized and converted into a rational function. But since we have a cube root cannot be rationalized. Okay, cube root cannot be rationalized. So this expression cannot be converted into a rational function. Excuse me. Hence, we will have to solve it as per the given expression. And in that case, there comes the application of the binomial expansion. So how do we do this? As I said earlier, for all limit extending to infinity cases, we take the highest power out common. So we do the same thing. So पहले bracket से x cube common ले लिया, we'll have a x 1 plus 3 by x to the power 1 by 3 minus यहाँ से भी x common ले लिया, mod x आएगा, but since x is tending to plus infinity, we'll keep it as a x 1 minus 2 by x to the power half. Now in both 1 plus 3 by x to the power 1 by 3 and 1 minus 2x to the power half, we apply binomial of rational index. We expand them by using the concept of binomial of rational index. So limit x tending to infinity. What would be the expansion over here? 1. यहाँ पे 1 plus है. So the expansion would be 1 minus nx plus n into n minus 1. So 1 by 3 minus 1, 2 by 3. N into n minus 1 by 2 factorial x square. So 9 by x square dot dot dot. As I said, expansions के लिए 3 terms are enough. Minus x into 1 minus 2 by x to the power half का expansion. So 1 plus nx plus n into n minus 1. So that will be a minus half by 2 factorial x square. So 4 by x square dot 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 dot. Is everyone clear with binomial of rational index? You can look into the notes. I had given you the expansion of binomial of rational index. Okay. Now let's look at the various terms that are assorted in this. So this would be limit x tending to infinity. Okay, the first term over here is x. The first term over here is minus x. So this one cancels off with this one. यहाँ तक clear है? Now the next term that we get over here, x cancel हो गया, 3 cancel हो गया, so that will be a minus 1. And the same term over here, x cancel हो गया, 2 cancel हो गया, will give us another minus 1. Okay. Plus. Now the next term that we get in this, अच्छा negative होगा उसमें, will be 2 by 2 cancel हो जाएगा, so that will be a 1 by 9, 9 cancel हो गया, and a 1 by x. x और x square में x बच जाएगा in the denominator. Same thing यहाँ पे 4 cancel हो गया, minus of 2x. Dot 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 dot. Achha, now, but as x tends to infinity, what will happen to terms with x in the denominator?
Zero.
This whole thing will tend to 0. Because the first set of terms over here has a x in the denominator, next में x square होगा, फिर x cube होगा, x power 4 होगा, सब denominator में होगा. And as x tends to infinity, all of those will tend to 0. So what is the answer that we get for it? minus 2. But more importantly, was everyone able to understand the mechanism of this binomial expansion? Okay. Okay, let's try another question on this. Suppose we have a question like this. Limit x tending to infinity, x plus 1 into x plus 2 into x plus 3 whole to the power 1/3 minus x. Again, we have a x tending to infinity and the power on the expression is a cube root. Cannot be rationalized. So फिर से binomial expansion लगाना पड़ेगा. So we start it in this way. पहले इसको expand करो. So limit x tending to infinity, this whole thing would be like x cube plus 3 to the 6, 6 plus 3 plus 2, 11x square. Sorry, 11 तो x आएगा. X square का तो term अलग आएगा ना. X square would be what? 3 plus 2 plus 1, 6. So plus 6x plus 11x square and 3 to the 6 plus 6 whole to the power 1/3 minus x. Here, as we did earlier, we take the highest power of out common from the root wala term. So limit x tending to infinity, x into 1 plus. अब ये हो जाएगा 6x square यहाँ होगा, x यहाँ होगा, sorry. So 6 by x plus 11 by x square plus 6 by x cube. And then whole to the power 1/3. अब since we want to use the binomial, तो binomial में तो दो term ही रख सकते हैं. So what we will do in this case is we'll regard 1 as one of the terms and this whole thing would be regarded as the second term of the binomial. Okay? Because binomial can only be obviously applied across a binomial. So now we use the binomial expansion. So limit x tending to infinity, x into 1, बीच में plus sign है, तो minus nx, तो n हो गया और x यहाँ पे होगा 6 by x plus 11 by x square plus 6 by x cube. फिर आएगा plus n into n minus 1 by 2 factorial and x का square, ठीक है, not writing it, और एक x. So now when we start to simplify like the previous case, तो यहाँ पे x into 1 will be a plus x. So this cancels off with the x outside. Then the first term that we get, तो x by 3 multiplied by 6 by x, तो x cancel हो गया, minus 1 by 3 into x will give us a minus 2. Does everyone follow this? Then the next term that we get, x and x square cancel होके x बच जाएगा. So that will be a minus 11 by 3x. Then next x और x cube से x square बच जाएगा. So that will be a 6 और 3 से 2 आ गया. So minus 2x2 by x square and dot 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 all the remaining terms. Now again, as x tends to infinity, what can we say? All terms from second term onwards will become 0. And hence what we get is the answer again. The limit of
Minus.
this is minus 2. Okay. Let's try another question. Is everyone done with this? Okay, then let's try another question on the application of binomial, something slightly different. So suppose we have question, limit n tending to infinity, cos square pi cube root of n cube plus n square plus 2n. Now, the reason I say that this is a slightly different scenario is because if you look at the previous two questions that we did, the previous two questions, both of them are in the form of infinity minus infinity. Is everyone able to understand this? दोनों infinity minus infinity form में है. But this one is not a infinity minus infinity form. It is just a simple n tending to infinity cos square pi and ये वाला तो infinity हो जाएगा. तो cos square infinite pi है ये तो. So how do we deal with this? So to solve this, what we do is we apply the property that to bring it into the infinity minus infinity form, which is basically what this question, this logic is, this particular formula is what this question is mainly based on. We have a formula which is if we have a cos square x, then cos square x can always be written as cos square of n pi minus x. Okay, where n can be anything. If n is 1, तो pi minus x होगा. Now, the reason why this would be true is, like suppose if n is 1, so this would be like a cos of pi minus x whole square. Now, cos of pi minus x is minus x, पर ऊपर में square लगा है, तो वापस से पॉजिटिव होके cos square x आ जाएगा. If n is 2, so this would be cos square 2n pi, 2 pi minus x. So 2 pi minus x will be an angle in the fourth quadrant. Cos in the fourth quadrant ऐसे ही positive है, तो cos square x आ जाएगा वापस से. And same goes for 3, same goes for 4. Okay. So sometimes you would have to apply these kinds of results from the external, from the outside, so as to understand or so as to create a required form in the expression. Okay. So using this relation, what we do is we write the limit as limit n tending to infinity cos square n pi minus pi times cube root of n cube plus n square plus 2n. ये एक की स्टेप है विच इज क्रिटिकली इंपॉर्टेंट. आप एग्जाम में ये कैसे सोचोगे, इसीलिए अभी कर रहे हैं. ठीक है. एनी क्वेश्चन दैट यू हैव, ट्रिगो का क्वेश्चन है जहां पे पाई एक समथिंग दिया हुआ है, implies that you have to apply allied angles. ठीक है, दैट्स इज अ थंब रूल. Any trigo question with pi inside, ठीक है, is to be solved by allied angles. काफी जगह काम आएगा ये. Right. So then we write this as limit n tending to infinity cos square pi कॉमन आ गया and ब्रैकेट में आ जाएगा n minus cube root of n cube plus n square plus 2n. Now this is an infinity minus infinity form, and then we can start solving this because it has now successfully been converted into an indeterminate form. So we can just solve the related part. This question can actually be modified to limit n tending to infinity n minus n cube plus n square plus 2n whole to the power 1/3. The reason I say this is because of the property that we had done, limit extending to a f of gx. क्या होता है इसके लिए? This becomes f limit extending to a gx. तो यहाँ पे cos square तो बाहर चला जाएगा, लिमिट अंदर शिफ्ट हो जाएगा. So we can just evaluate the limit of the inside part, and जो भी value आए वहाँ पे back substitute कर देना. So this is limit n tending to infinity n minus, we take the highest power out common, 1 plus 1 by n plus 2 by n square to the power 1 by 3. अब इस केस में just like the previous case, 1 by n plus 2 by n square, this would be considered to be the second term. And then we apply binomial expansion, n tending to infinity, n minus n, 1, यहाँ पे प्लस है, तो माइनस nx. क्या करके आया? बाहर का नेट बंद करके आया क्या? So as we were discussing, sorry for the interruption. So as we were discussing about this, ये n minus n taken common, 1 plus 1 by n plus 2 by n square हो जाएगा, where 1 by n plus 2 by n square would be treated as the second term. And then this would be limit n tending to infinity n minus n times 1. यहाँ पे प्लस है तो यहाँ पे माइनस आएगा, माइनस n x, तो 1 by n plus 2 by n square plus n into n minus 1 by 2 factorial blah 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 blah, जो भी square whatever नहीं चाहिए, काम का नहीं है. And then again, so the first terms in this one cancels off with the n outside. तो अंदर में जो फर्स्ट टर्म मिलेगा in this case would be minus minus cancel होके 1 by 3. And n cancel हो गया. फिर the second term that we get in this would be a minus minus plus 2 by 3n plus dot dot dot. Now, as happens earlier, all the terms from here on will contain a n in the denominator. So with limit n tending to infinity, all of them tend to 0, and we get the answer as 1 by 3. So the value of this limit is 1 by 3, which we then actually put back over here. So this ends up becoming cos square of pi by 3. What is the value of cos square pi by 3?
1 by 4.
1 by 4. That will be the final answer of the question. So limit n tending to infinity, cos square pi cube root of this, blah, blah, blah. The answer is 1 by 4. More importantly, was everyone able to understand this process? Application of binomial expansions is a very important method that we have to solve problems of this particular type, trigger type questions of this form. Is everyone clear with this? Okay. तो then आगे बढ़ते हैं. Okay, next question. Again, easy one. Just to change things up. Limit extending to 0. 5 by 2 plus root over of 9 plus x whole to the power cosec x. Whole to the power cosec x. What is the form of this limit? Can anyone identify the form of the limit?
1 power infinity.
Correct, 1 power infinity. So since it's a 1 power infinity form, we solve it by the standard method. Limit extending to 0 e to the power gx into fx minus 1. So 5 minus 2 plus root over of 9 plus x by 2 plus root over of 9 plus x. So this would be limit extending to 0 e to the power. अच्छा, we can write this as 1 by sin x. And ऊपर में आ जाएगा 3 plus root over of 9 minus x, 9 plus x by 2 plus root over of 9 plus x. अरे सॉरी, माइनस में आएगा ना, क्योंकि ये भी माइनस होगा यहाँ पे. अच्छा, what do we do next? Anyone? Rationalize the numerator. So limit extending to 0 e to the power 1 by sin x. Now when we rationalize the numerator, this will be like a 9 minus 9 minus x divided by 2 plus root over of 9 plus x into 3 plus root over of 9 plus x. तो अब यहाँ पे 9 और 9 कैंसिल हो गया, माइनस x बचेगा. And sin x by x as x tends to 0. So we can pair it as x by sin x into 1 by ये पूरा part 2 plus 9 plus x 3 plus 9 plus x with a negative outside. तो अब sin x by x 1 हो गया. अब इसमें वैल्यू डालो तो 3 plus 2 this would be 5 and 3 plus 3 this would be 6. So what do we get as the answer? E to the power minus 1 by 30. Was everyone able to follow this? Okay, next question. Limit n tending to infinity cos of x by root n whole to the power n. Cos of x by root n whole to the power n. Again, what will be the form of this limit? So as n tends to infinity, x by root n will tend to 0. Cos 0 is
1
1.
power infinity.
तो फिर से 1 power infinity है. Solve it as such. So limit n tending to infinity e to the power gx into fx minus 1. So cos x by root n. And we get a minus 1. ठीक है. अब cos के लिए what is the standard limit?
One minus cos.
Cos x by root n minus 1 divided by x by root n का whole square. Which means we are multiplying it with x square by n as well. ठीक है ना. 1 minus cos of something by that something square. तो x by root n है cos के अंदर, तो x by root n का square चाहिएगा to convert it to a standard limit. So cos of something minus 1 by that something square into by that something square. So अब this n cancels off with this n. And what would be the value of this whole part? इसका वैल्यू क्या आएगा? Anyone, what will be the limit of that part?
Half.
Minus half. Cos minus 1 है. Started में 1 minus cos होता है. Please be careful of these things. So the answer of this would be e to the power minus x square by 2. Remember, x will be part of the answer. Limit is applied on n, so x would be treated as a constant. X को गायब मत कर देना. This would be the answer, e to the power minus x square by 2. Okay. Next. Next question. Limit x tending to infinity 1 to the power 1 by x plus 2 to the power 1 by x plus 3 to the power 1 by x going up till n to the power 1 by x divided by n whole to the power nx. Okay, same question to begin with. What is the form of this limit? Again, this is a 1 power infinity form. As x tends to infinity, 1 by x सब जगह पे 0 हो जाएगा. 1 power 0, 1, 2 power 0, 1, 3 power 0, 1, n power 0, 1. So n terms with value 1 is n by n, 1. और x तो infinity जा ही रहा है. So it's a 1 power infinity form. Is everyone clear on how this is a 1 power infinity form? So then we solve it as limit x tending to infinity e to the power nx into 1 to the power 1 by x plus 2 to the power 1 by x plus 3 to the power 1 by x plus so on so forth n to the power 1 by x minus n whole divided by n. तो ये n और ये n cancel हो गया. अब to solve this further, we convert this into standard limits. E to the power 1 to the power 1x minus 1 plus 2 to the power 1 by x minus 1 plus 3 to the power 1 by x minus 1 going all the way up till n to the power 1 by x minus 1. ठीक है, और ये जो x है यहाँ पे इसको सबको दे दिया एज अ 1 by x. So this ends up becoming a to the power something minus 1 by that something as that something tends to 0. So what is limit of a power something minus 1 by that something as that something tends to 0? ln a. So you get ln 1 plus ln 2 plus ln 3 going up till ln n, which is simplified as e to the power ln of n factorial. And the final answer that we get is n factorial. The limit of this is n factorial. Is everyone clear on the question?
Yes, sir.
Acha, next question. Limit x tending to infinity, x into 1 minus x into log of 1 plus 1 by x. Find the value. Limit x tending to infinity, x into 1 minus x log of 1 plus 1 by x. Again, mechanisms of solving, we use series expansion for this. The easiest way would be. So this is like writing x minus x को अंदर multiply कर दो तो x square and a log of 1 plus 1 by x. And यहाँ पे series expansion लगाना है. तो log of 1 plus 1 by x would be 1 by x minus x square by 2 factorial. So 1 by 2x square plus x cube by 3. So 1 by 3x cube dot dot dot. आगे लिखना नहीं है. 3 terms as we had already mentioned. So this becomes limit x tending to infinity x minus. अच्छा, x square into x पहला टर्म आएगा x. फिर अगला टर्म आएगा x square कैंसिल होके हाफ. फिर अगला टर्म आएगा माइनस में 1 by 3x and dot dot dot. तो ये x और x कैंसिल हो गया. Half will remain as it is. And as x tends to infinity, what will happen to the terms 1 by 3x onwards? ये सारा 0 हो जाएगा because
Zero.
they will have a x in the denominator. So the value of the limit is half. सारा सीरीज एक्सपेंशंस याद रखना होगा. As I said, all of it is very, very important. Okay, next question. Limit extending to 0. One plus x to the power 1 by x minus e whole divided by x. Okay, mechanism of solving this would be we convert to standard limits. Although 0 by 0 form है लापता लगा सकते हैं पर 1 plus x to the power 1 by x का differentiation अभी तक we haven't done. We'll do this in method of differentiation. How do we do a fx by fx to the power gx का derivative? So we'll go for series well rather standard limits. So if you notice ये 1 plus x to the power 1 by x 1 power infinity form है. And for all 1 power infinity forms, we write them as e to the power ln. So ये हो जाएगा 1 plus x to the power 1 by x minus e whole divided by x, which is like limit x tending to 0, e to the power log of 1 plus x by x minus e whole divided by x. Up to convert this into standard limits, what we do is we take e out common. E common ले लो पूरे expression से. So this will become e to the power log of 1 plus x by x minus 1 and a minus 1 whole divided by x. अब e के लिए what is the standard limit? E to the power something minus 1 by that something. तो यहाँ पे e to the power something में ये पूरा part है. So we convert to the standard form in this way. Limit x tending to 0, e to the power of log of 1 plus x by x minus 1 whole divided by log of 1 plus x by x minus 1 into ln of 1 plus x by x minus 1 whole divided by x. देखो ये समझ में आया? Okay. And for the second part of this, okay, we just take the LCM and rewrite this whole thing as, इसको next step में लिख देंगे log of 1 plus x minus x divided by x square. Okay. So that this would be limit x tending to 0. अच्छा ये तो standard limit बना हुआ ही है. So this is e into e to the power log of 1 plus x by x minus 1 divided by log of 1 plus x by x minus 1. ये तो सेट है, इसमें कुछ करना नहीं है. अब बस खाली इसको सेट कर लेते हैं. log of 1 plus x के लिए एक्सपेंशन लगा दिया. तो x minus x square by 2 plus x cube by 3 dot 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 minus x by x square. तो ये x एज यूजुअल कैंसिल हो गया. एंड लिमिट एक्सटेंडिंग टू 0, अब देखते हैं। तो वी स्टार्ट फ्रॉम दिस। E to the power something minus 1 by that something as that something tends to 0, ये हो जाएगा 1। एंड सेकेंड पार्ट में रैशनल फंक्शन हो गया, x टेंडिंग टू 0, कोफिशिएंट ऑफ द स्मॉलेस्ट पावर चाहिए, स्मॉलेस्ट पावर है x स्क्वायर का। सो द लिमिट ऑफ दिस, द फाइनल आंसर ऑफ दिस विल कम आउट टू बी, यहाँ से e इंटू, और यहाँ से कोफिशिएंट आ जाएगा -12, सो -e/2 इज द आंसर। Please go through this question once again and make sure that everyone has understood the question. It's just that I'm not sure that whether people have done fx to the power gx का derivative or not. इसलिए I'm doing it in this way for now. Is anyone clear with this? Okay. Next question. Limit extending to 0, sine of pi cos square x divided by x square. Okay, again, this would be an example of something that we did the thumb rule earlier. We have a trigo limit with a pi inside. So this means it's a question based on allied angles. So we use इस case में, since we have a cos square, so we do it in this way. Standard form limits में convert करने के लिए, we write it as sine theta is always the same as sine of pi minus theta. So cos square x divided by x square. So that this can be written as limit extending to 0, sine of pi into 1 minus cos square. अब साइन के लिए स्टैंड लिमिट कैसे बनेगा? साइन ऑफ समथिंग बाई दैट समथिंग, तो एडजस्ट करने के लिए इनटू 1 माइनस cos square x डिवाइड बाई x स्क्वायर। ये सारा स्टैंड लिमिट बन गया। नाउ साइन ऑफ समथिंग बाय दैट समथिंग एज द समथिंग टेंड्स टू 0, तो ये पूरा हो जाएगा 1। this whole thing would be 1. And 1 minus cos square x by x square as x tends to 0, ये हो जाएगा half. So the answer of the limit is
pi by
pi by 2. Okay, next. A very similar question, just to, reiterate the same fact. Suppose we have limit theta tending to 0, tan of pi cos square theta divided by sine of 2 pi sine square theta. So in this case, for the numerator, we write it as limit theta tending to 0, क्योंकि cos square के लिए 1 minus cos square का form चाहिए होता है. So we write it as tan of pi minus pi cos square theta. But tan of pi minus theta is minus theta, तो minus बाहर आ जाएगा. Divided by sin के लिए तो we can just simply do a sin square theta को 1 minus cos square theta कर दिया. ये तो directly convert हो जाएगा. ठीक है. And then converting to the standard form. So minus of tan of pi minus 1 minus cos square theta. तो tan of something, by that something चाहिए into pi times 1 minus cos square theta into, अच्छा sin के लिए भी सेम ही है, तो sin of something को भी वही something चाहिए, तो 1 minus cos square theta into 1 by 2 pi into 1 minus cos square theta. या यही वाला, एक्चुअली यही वाला ले लो ना, क्यों एक्स्ट्रा लिखना है इतना. तो इसके स्टैंडर्ड फॉर्म के लिए ये आ ही रहा है, तो इसका ही ये वाला ही यूज कर लेते हैं। तो डिवाइड बाई आएगा साइन ऑफ 2 pi into 1 minus cos square theta. So all we have to do is multiply and divide by 2 to get tan of something. So tan of something by that something as the something tends to 0. 1. फिर ये हो जाएगा sin of something by that something as that something tends to 0. 1 and half बचेगा. Does everyone follow this?
Yes.
अच्छा
Minus
माइनस
half.
हाफ होगा, सॉरी माइनस भी तो है बाहर. माइनस हाफ. Okay. Next question. If alpha, beta are the roots of the quadratic ax square plus bx plus c equal to 0, then find limit x tending to beta 1 minus cos of ax square plus bx plus c whole divided by x minus beta square. So how do we do this limit extending to beta? If alpha and beta are the roots of the quadratic, so how can we also write down the quadratic as
A into x minus alpha into x minus
a
beta.
into x minus alpha, x minus beta? So this is like writing 1 minus cos of a into x minus alpha into x minus beta by x minus beta square. But cos का स्टैंडर्ड फॉर्म बनाने के लिए क्या चाहिए? 1 minus cos of something by that something square. So we have to multiply by x minus alpha square. So यहाँ पे भी आ जाएगा a square x minus alpha square. तो अब as x tends to beta, this is 1 minus cos of something by that something square. तो इसका वैल्यू क्या हो जाएगा?
1/2.
ये हो गया हाफ एंड यहाँ पे फिर लिमिट बैठा दो. So the answer that we get for this, the answer of this would be a square
Alpha
alpha
beta
minus beta whole square by 2. Beta minus alpha, alpha minus beta एक ही बात है, स्क्वायर के अंदर है, डजेंट मैटर. ठीक है, इट डजेंट मैटर क्योंकि स्क्वायर के अंदर है. सिंपल क्वेश्चन. Okay. Next question. If limit x tending to 0, alpha x minus e to the power 3x minus 1 by alpha x into e to the power 3x minus 1 is equal to beta. Find alpha and beta. So for finding unknowns, we always use series expansion. Finding the value of the unknowns के लिए series expansion use करते हैं. So that is what we do for this question as well. We say that, okay, this will be limit x tending to 0. Alpha x minus e to the power 3x का expansion होगा 1 plus 3x plus 9x square by 2 factorial plus 27x cube by 3 factorial dot 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 and plus 1 divided by alpha x. So 1 plus 3x plus 9x square by 2 factorial dot 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 minus 1. तो अब देखो क्या होगा, 1 1 यहाँ पे कैंसिल हो गया, 1 1 यहाँ पे कैंसिल हो गया. And since we have a limit extending to 0 rational function, we need the coefficient of the smallest power. So what is the smallest power right now? Coefficient of x चाहिए. तो यहाँ पे alpha minus 3 by denominator में तो 0 हो गया. So what does this imply? As long as the smallest power is x, the limit cannot exist. But it is given that the limit exists and is equal to beta. So we'll have to get rid of the coefficient of x, implying alpha is 3. Then we look for the next highest power. So coefficient of x square, smallest power, sorry, next smallest power, x square. So x square the coefficient would be minus 9 by 2 in the numerator and 3 alpha in the denominator. So 3 alpha 9 हो गया. So ये 9 cancel होके we get beta is minus half. So alpha is 3 and beta is minus half. Was everyone able to follow this? Is everyone clear with all the questions that we have discussed today? We'll stop at this since it is nearing 12. So तुम लोग को भी सोना रहेगा and I definitely have to sleep. Early morning class है. So we'll stop at this for today. This was like one set of questions that we have discussed on limits. Now we'll have another session on limits. We'll to discuss another set of questions and type of questions, another type of questions that we have on limits. But is everyone clear with the questions that we have discussed today? अरे हाँ या ना तो बोल दो.
Yes, sir.
Okay, chalo. So we'll wind it up at this for today. If you have any doubts from the session today, you can ask me in the classes tomorrow and on Sunday. Okay, over the weekend. So bye everyone. Good night.
Thank you, sir. Bye.